This is practice A for section 4.4. This is the back. We're going to decide whether the figure is stable, and we're going to explain our reasoning. Well, before we even start, triangles are the most stable shape. They're a rigid shape because it's impossible for them to change into a different triangle. If you have three side lengths and those connections are not going to split apart, it's impossible for a triangle to turn into a different triangle. So whichever shape has the triangles is going to be the most stable figure. So if we didn't have this cross brace here in this four-sided figure, this four-sided figure could potentially shift into another four-sided figure that has the same side lengths. But if you put this cross brace in here, that forces two triangles in the figure. And these triangles do not change shapes. That's impossible. That's why if you drive across a bridge, the shape that you're going to see the most are triangles. So, is this figure stable? Yes. Is this figure stable? It's not going to be. There's no triangles. Number 11 and 12, there's a good bit of work involved in these. Use the given coordinates to determine if the triangles are congruent. So we're talking about triangle ABC. So here's A, B, and C. Here's triangle DEF. DEF. Are those triangles congruent? Well, you could plot these if you want on graph paper if you have that. You could use a straight edge and connect them, and you could see if they look like they're congruent. That's not a bad way to do it. But the better way to do it is to find the distance between these ordered pairs. Then find the distance between these ordered pairs. Then find the distance between these ordered pairs. What you're actually doing is finding the length of all three sides of this triangle. Then find the length of all three sides of that triangle. You do that by using the distance formula. So if you don't remember the distance formula, that's from chapter 1. There it is right there. Here's your three coordinates A, B, and C. Plug those in. Calculate the exact length for those sides. Then you got to do the same thing for the other triangle, DEF. Calculate those lengths. You're using the distance formula 6 times. But notice what happens. Are these sides congruent? That's one pair. Here's another pair of congruent sides. Here's a third pair of congruent sides. If you got 3 pairs of congruent sides, your triangles are congruent by side, side, side. So number 11 is yes. Number 12, I didn't work out. But this is how you do it. Use your distance formula. Now, just so you know, this segment doesn't have to go with this one. This segment could match up with this one, or this one could match up with this one. 3 pairs of congruent sides just means you have 3 matches somewhere. It doesn't have to be straight across. 13 and 14, determine whether the triangles are congruent and explain your reasoning. So there are 2 triangles here. I notice there's a pair of congruent sides here. There's also a pair of congruent sides there. The third sides we're not sure about. I see congruent parts of triangles, but segment AF is not an entire side of that triangle. Segment AC is. Okay, so let's just pretend for a second that segment FC has a length of, I'll just make it easy, let's pretend it's 8. Well then how far is it from A to C? It would be 10. How far would it be from D to F? It would also be 10. So we're using that reflexive property and our segment addition postulate to say that these lengths actually are the same. So if you got 2 pairs of congruent sides and then 2 sides that have the same length, you actually got 3 pairs of congruent sides. So yes, they're congruent by side, side, side. You're using reflexive and segment addition there. This one, same kind of concept, except it doesn't work out as well. You got congruent sides here, you got congruent sides here, that's 2 S's, but you can't get the third pair of S's because this part that's 3 and this part that's 2 don't match up. This segment is congruent to itself, obviously, but if I would just make up a number here, let's pretend that's 4. Notice how this is 6 and this is 7. Those don't match. So I'm going to say segment FE is not congruent to segment CB. So the triangles are not congruent because you don't have three pairs of congruent sides, you only got two. Number 15, two different gates are shown. These are gate doors. Which door frame is stable? Explain your reasoning. Okay, well, as long as this stays connected, these shapes are not going to morph into a different type of triangle. But this four-sided figure, even if these corners stay together, they could shift into a different shape. This could slide over and look more like a parallelogram than a rectangle. The stable shapes are the triangles. You need triangles.